All right, we have Module 7, which is about increasing, decreasing maxes and mins, and what's about concavity and points of inflection. So actually, let's write that down real quick. If you see the words maximum or minimum or increasing or decreasing or critical points, then all of that is a first derivative. Okay? So if you see the words maximum, minimum, increasing, decreasing, critical points, those terms, that vocabulary, should tell you to take a first derivative. If you see the words concave up, concave down, or points of inflection, that all tells you a second derivative. Okay? So those are your vocabulary words which should tip you off how many derivatives to take. Okay, so maximum, minimum, increasing, decreasing, critical points is all first derivative. Concave up, concave down, points of inflection are all second derivative. Okay, so that should be in your back pocket in case you need it. So here we have Module 7. We've got a function f of x equals 4x to the third minus 10x. And I want to know where my function is increasing and decreasing and where I've got maxes and mins. So what we're going to do is take a first derivative, but before we do that, we need to know what the domain is. So our domain, what does your gut say? Your gut should say all real numbers. And your gut is correct. Okay? So my domain is all real numbers. When is it not all real numbers? When you have variables in denominators, it could have a restriction on it because you don't want your denominator to equal 0. When you have, let's write this down too. So if you have is all real numbers unless you have a variable in your denominator that says denominator. Okay? In which case you take your denominator and say it's not equal to 0 and solve, because you never want to divide by 0. What else have we got? Even roots. Like a square root or a fourth root or a sixth root, as long as your root is even. Take your argument, which is the stuff underneath the radical, and say it's got to be greater than or equal to 0. What if I have a logarithm? A logarithm, you don't want your argument to be 0 and it's got to be positive. So you're going to take the argument and say greater than 0. Okay, so those three things are important. If these three things don't happen in business calculus, then your domain is all real numbers. Okay? So, let's go back to what we were working on. if I have 4x to the third minus 10x, the first thing I look at is domain. So my domain is from negative infinity to positive infinity. It's all real numbers. The second thing I do is determine how many derivatives to take. So when I say that I want to know its maximums and minimums, then that tells me first derivative. So my first derivative is going to be what? 12x squared minus 10. Okay, what do we do with that? We set it equal to 0. So first thing I did was find the domain. Second thing I did was took a derivative and set it equal to 0. I'm going to add 10 to both sides. Okay, divide both sides by 12 because we're trying to get x by itself. So 10 twelfths reduces to 5/6. I'm going to take a square root of both sides. What did you better not forget if you're taking a square root during the process of solving a problem? You better not forget your plus minus. So I have x equals a positive root 5/6 and a negative root 5/6. And that 6 is underneath the radical. So that's why the radical is so tall, because that 6 is underneath there. All right, so we make a number line. First thing that we did was find the domain. Second thing that we did was take a derivative and set it equal to 0. So these are my critical points. So I've got negative root 5/6. And I've got positive root 5/6. And this is approximately equivalent to, and I get negative 0.9129. Okay? So what I have is 3 different intervals. So if I have these 3 intervals, what am I going to do? I am going to find a number over here to test. So what's the number to the left of negative root 5/6? What's the number to the left of negative 0.91? I can use negative 1. So I'm going to use negative 1 as a test point. Where do I test it? I test it in my first derivative. So we've got negative 1 times 12. Negative 1 squared times 12 minus 10 gives me a 2. So it's increasing this way. What's the number between these two that's lovely? I'm going to use 0. So that zeroes this out, and I get a negative 10. So it's negative. And what about after 0.9129? After 0.9129, we're going to use 1 again. Okay, so 12 times 1 minus 10 is positive. Okay, so what do I have at negative root 5/6? I have a max. What do I have at root 5/6? I have a minimum. At root 5/6. You can't see what I'm doing. Okay. Okay, I got interrupted and distracted, but I'm back now. All right, so we know where it's increasing, we know where it's decreasing, we know where it's increasing. So where is my function increasing? It is increasing from negative infinity until I get to negative root 5/6. And again, from root 5/6 to positive infinity. Where is my function decreasing? Decreasing from negative root 5/6 to positive root 5/6. Okay, let's try another one. So what if I have something like f of x equals 2x over x squared minus 9? So first thing I want to do is take care of my domain. So I see variables in denominators, which means it may not be all real numbers. So I'm going to take my denominator and say you cannot equal 0. So I'm going to add 9 to both sides. I get x squared is 9. Take a square root, and I get x is, don't forget your plus minus, positive or negative 3. I should say can't be. Okay, so x can be everything but positive 3, everything but negative 3. So we've got to use those as partition points because it may change increasing, decreasing there. But remember, it doesn't exist there. So what is my domain? My domain is from negative infinity to negative 3, from negative 3 to positive 3, and again from 3 to positive infinity. So that's my domain. And now we can dive in. I just want to know increasing, decreasing, maxes, and mins. So that means how many derivatives? That means one derivative. So I have f prime of x equals, what rule am I going to use? I've got variables divided by variables, so that tells me to use quotient rule. Okay? So I've got the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Okay, so that thing needs to be equal to 0. So again, if I use a negative 3 or a positive 3, I'm going to have a denominator that's undefined. Or the denominator would be 0, which would make the function undefined. So I'm just going to clean up the numerator real quick. I'm going to distribute this 2. So I have 2x squared minus 18, and then minus 4x squared, all over x squared minus 9 squared. So I distributed the 2, and I distributed the negative 2x. So when I put that together, 2x squareds minus 4x squareds is going to be a negative 2x squared minus 18 over x squared minus 9 squared. Okay? So what do I do now? The only way to make a fraction equal 0 is for its numerator to equal 0. And I just made up this problem, so hopefully we go someplace good. All right, so my numerator is negative 2x squared minus 18 is 0. And I'm going to divide both sides by negative 2. And that's going to give me x squared plus 9 is 0. So subtract 9 from both sides. And I have x squared equals negative 9. Square root both sides, and then immediately you should stop. This is impossible. Okay, so my only points that I need to worry about are my partition points from the domain. Okay, and we'll test those in the derivative, which I can test this one because it's cleaned up. Okay, so I've got a negative 3, and I've got a positive 3. So what's a nice friendly number to the left of negative 3? I can use negative 4. So I have 2, negative 2 times negative 4 squared minus 18 gives me a negative 50. And whatever I put in the denominator is going to go positive because I'm squaring it. So I've got a negative over a positive, so that means it's negative. Okay, what about between negative 3 and 3? Well, 0 works. So if we put in a 0, I get a negative 18 over something positive. I'm checking something. Negative 2 times negative 4 squared minus 18 is negative 50. Okay, what about after 3? After 3, we have 4. So negative 2 times 4 squared minus 18 gives me negative 50. So that's negative again. So I don't have a maximum or a minimum, but I am decreasing over 3 intervals. So I'm decreasing from negative infinity to negative 3, from negative 3 to positive 3, and from 3 to infinity. Okay? So let's try one with concavity. So my concavity means second derivative. So I'm given that function. What's my domain? My domain is all real numbers. And I want concavity, so how many derivatives am I taking? I am taking 2 derivatives. So the first derivative gives me 6x squared plus 8x minus 9. And then we go in and take a second derivative, which gives me 12x plus 8. And set that equal to 0. This is where our test points are going to go. So subtract 8 from both sides. And then divide both sides by 12. Negative 2/3. Okay. So I have a possible point of inflection at negative 2/3. Oh, good grief. I just messed up this whole thing. 3 times 3 is 9, which makes this, I'm glad I looked at that. This makes 18. And I subtracted 8. I divide both sides by 18. I'm so sorry. I suppose I could have paused the video while I do this. 4/9. All right. So, now that that's fixed, I need a number to the left of negative 4/9. So I'm going to use negative 1. So 18 times negative 1 is negative 18 plus 8 is negative. And what's the point after negative 4/9? Is 0. So I get a positive 8. So remember, you're dealing with a second derivative. So this doesn't talk about increasing and decreasing. This talks about concavity. So I'm concave down. From negative infinity to negative 4/9. And I'm concave from negative 4/9 to positive infinity. Where is my point of inflection? I've got a point of inflection at x equals negative 4/9. Okay, let's try one more. Okay, what's my domain? My domain is all real numbers. So what do I do first? If I'm looking for concavity, how many derivatives is that? That is 2 derivatives. So I have my first derivative is 12x squared minus 9. My second derivative is 24x. So that's where my test points are going to go. And that's supposed to be equal to 0. So divide both sides by 24. And we get x equals 0. So on my number line, I have a possible partition point at 0 or a possible point of inflection at 0. Okay, so what's a nice friendly number to the left of 0? Try negative 1. So 24 times negative 1 is negative. What about a number after 0? We can use a million. So 24 times a million is positive. So where do I change concavity? I'm concave down. From negative infinity to 0. From 0 to positive infinity. And where do I have a point of inflection? At x equals 0. Okay, and that's Module 7.